Section 5.1, and we'll call this 5.1b if you want to call it that, whatever. Because this is like the second part of what we did yesterday. What did we talk about yesterday? What was the main thing we talked about yesterday? We started off. Before we did that, perpendicular bisectors, okay? So we did a perpendicular bisector of a segment, right? We took a segment, we split it in half, split it into two equal parts. That means that we bisected it, and then we drew a line that's perpendicular, okay, at that point right there where it bisects, okay? So that's a perpendicular bisector. Today we're going to talk about angles, so let's draw an angle. Okay, we'll draw one like this, we'll draw one like this, and there are going to be some similarities to what we did yesterday. All right, and we're not going to do a perpendicular bisector, but we have done this before. What do you think we'll do with this angle right here? It's a word that was similar to what we did yesterday. What do you think? You can do a perpendicular bisector this. We got an angle. What can you do with this angle? Yeah, let's bisect the angle. Exactly right. So let's bisect the angle, and let's talk about that bisector. All right, and let's do this. I don't know. You can't see the difference in the colors too much anyway, can you? No. Let's do this. Let's go blue. I think you can tell. All right, go ahead and turn them off. Yes. All right, now I can't see. All right, so watch what I'm going to do. Now, again, we're going to have to eyeball this a little bit. That pretty much looks like it's bisecting, doesn't it? Those two angles are equal, about right in there. Okay. All right, so now the bisector technically is a ray. And because the angles, remember we defined angles way back? The angles are two rays that meet at a common endpoint right here. All right, so we're saying that this thing is bisected right now. So let's do that. Let's put that in red. So I'm telling you that that's a bisector, which means if that's a bisector, then those two angles are equal to each other. Everybody with me so far? Let's do this. Let's put a point anywhere on this bisector. I don't care. So let's put a point, I don't know, right there. It's no magical place or anything. I just picked any place on that bisector, and I put a point. Now, what this first theorem says, this is called the angle bisector theorem. All right, let's write that down. So it's called the angle bisector theorem. I'll just shorten theorem right there. Which basically says this. I'm not going to read it word for word, but if you have a point that lies on the angle bisector, okay, now remember, when I say angle bisector, that assumes you know a couple things. You know that these two angles are equal to each other. All right, so if I have a point that lies on the angle bisector, that point is equidistant, which means the same distance from the sides of the triangle, or not the triangle, the angle. Hear what I said? This point right here, if it's on the angle bisector. Now, look, if it's up here, this wouldn't work. Okay, if it's down here, it wouldn't work. But if it's right on this line, this angle bisector, it's equidistant from the two sides of that angle. Now, we talked just not too long ago about being equidistant from something. Now, if I said the distance from this point to this ray right here, how would I draw that? Would it be from here to here? Is that the distance from that point to that ray? Is it from here to here? Is it from there to there? If it's perpendicular. Very good. You remember that? Okay, so it's perpendicular to that side. Okay. Actually, I meant that to be red. Let's yeah, let's just make these red and make that red. Okay. All right. So now there's the perpendicular. That's the distance from this point to this ray right here. That side of the angle. So what did I say about that point? It's equidistant. So the distance from this point to this ray is the same as this point to what? The other ray. So how would I draw that? I would draw that from this point where? Perpendicular. Not to the middle. Perpendicular. Okay? Because you don't have a middle anyway, because it's a ray. You don't have the middle of a ray. But it is perpendicular to that side of the angle. All right? And what do we say? It's equidistant. So what's true about these two little red lines right here? They're equal to each other. So I can put a little tick mark here and a little tick mark right there. Does that make sense to you? So again, let's say it. If I have a point that's on the angle bisector, it's equidistant from the sides of the angle. So when I say it's equidistant, what distance am I talking about? I'm talking about that perpendicular distance. I'm not talking about from this point to here, from this point to here. Okay, I'm talking about the perpendicular distance from this point to the other side. Everybody got that? Okay. Now that's the angle bisector theorem. I'll just leave it like that. I was going to put some letters in here. If you look in the book, they do that, but I think that might just confuse you more. I think that's good enough for an explanation. But now what we're going to do, now what was given to you, first of all? Let's write down what was given. It was given, I guess I should probably put, yeah, let's do it. Sorry, I said I wasn't going to, and I changed my mind. All right, so we'll put some letters in here. So what was given? It was given that that point did what? Well, it lies on the bisector, and so it must be given that BF is the what? Is the bisector. Okay, so BF, ray BF, is the angle bisector. Or you know what I'm going to do? I'm just going to say bisects. Bisects what? Angle. No, it only bisects one angle. It's DBE, right? Angle DBE. Good. All right. So it's given that this bisects angle DBE. So if it bisects, what can I say about F? Okay. So it's given this thing. Then what could I say? If this is true, if BF bisects this, what can I say about this little segment right here? I can say that DF is what? Is perpendicular, first of all, right? Okay, so I can say that DF is perpendicular to BD. And BD is a ray, DF is a line segment. And I can also say that, what else? DF is perpendicular to DB. I could also say what? Come on, EF, that's right. EF is perpendicular to what? BE, that's right. So I could also say, I'll put a comma here, could also say that EF is perpendicular to BE. Right? EF is a line segment and BE is a ray. What else could I say? Somebody said it earlier. I could say that they're perpendicular, and I can also say that what else is true about DF and EF? They're what? I can't hear you mumbling. They're equal to each other. That's right. They're equal. Okay, so I could say that DF is equal to EF. All right? So what were we given? We were given that just F lies on an angle bisector. So we were given that this is an angle bisector. And it's shown by those two angles being equal to each other, right? So you know that that's an angle bisector if those two angles are equal. So what can I say? If I know that situation, I know basically two things. I know that these two line segments are perpendicular to the sides of the angle, and I also know that the lengths of those two line segments are actually equal to each other. You okay with that? What if we had a situation? Let's see if I can grab everything here without... No, sorry. Let's try this one more time, sorry. I could just write the rest of it in there. I'm going to copy and paste and put this down here. Now, we did this yesterday. What do you think we're going to do now? We had the angle bisector theorem. What are we going to have now? The converse of it. Very good. Okay. So now, let's do this. Let's write converse of the angle bisector theorem. Okay, I'll write all that down. You guys writing this down too, aren't you? Alright, so this is the converse of it. Now look, if I wanted to, instead of saying given, I could use what if I turn this into an if-then statement? I could say if. Oh, what did I do? Okay, if. Oops. For some reason I changed... all that stuff. Alright, try one more time. So if BF bisects this, then that means that this stuff must be true. Alright? And that should be an F right there. Okay. So if all this stuff is true, what do we do when we do the converse of something? We just talked about this yesterday. Yeah, so what's the if going to be? If DF is perpendicular, right, to BD, and if EF is perpendicular to BE, right? So really, I'll tell you what, just to save me, maybe not. Thought I was being slick. I could grab all that stuff, but I'm going to grab that too. That's all right. Let me just write it down. Stop being lazy. So if DF is perpendicular to EF, right? And what else? If, I'm sorry, I lied. Let's try that again. If DF is perpendicular to what? BD, sorry about that. BD, and what? EF is perpendicular to BE, and one more thing, what else? Good, and if DF equals EF, alright, if all that stuff is true, then guess where F is? Lies where? It lies, no, it's not the center. We never said center one time yet. Okay, F is what? It lies where? On the what? On the angle bisector. Okay, so we could say, you could say F lies on the bisector, but we're going to say this. Then what? Then ray BF, what? Bisects angle DBE. Alright? So watch. Here's your information. Here's point F. It's perpendicular to D. It's perpendicular to E. DF and EF are equal to each other. So guess what must be true about this blue line? It must be a what? An angle bisector. Which means, what must be true about the angles then? That this angle must equal this angle. You see that? So if this is the angle bisector, these two angles must be equal to each other. Does that make any sense? Alright, so that's what you're going to see. You're going to see some pictures. You're going to see some stuff. You might see it's given that these two angles are equal, and then they may say, like, this side is 5. What would you say EF is? You would say that's 5. Would you agree? Okay, they might come over here and say, okay, it's perpendicular. They say that length is 3, that length is 3. This length right, or let's say, let's be a little bit tricky. Let's say that whole angle right there is 60 degrees. Then what's this little angle and what's this little angle? They're both 30. Does that make sense? So it's pretty easy. But you got to know all that stuff. You got to know that it's perpendicular, and you got to know that they're equal to each other. If you know all that stuff, then this angle and this angle are equal to each other. Make sense? If you know these angles are equal to each other, what can you say about these two lengths? They're perpendicular and they're equal to each other. Exactly right. Does it make sense? Okay, so that's the kind of stuff that you're going to do on this. So you've got the regular theorem, the angle bisector theorem, and then you got the converse of the angle bisector theorem. Now we're going to use this just like we did yesterday. Remember we did that circumcenter? We did the perpendicular bisector, then we took a triangle. We found the perpendicular bisector of all three sides. Yes? Do you remember that? We're going to do the same thing, except we're not going to do the perpendicular bisector of all three sides. What do you think we're going to do to the triangle? Find the what? Yes, very good. The angle bisector. Okay, we're going to find the angle bisector of all three sides of a triangle. So let's do that. We'll do that in the next video.